Hello, welcome to this video on wind energy technology. In this session, we will be diving into the challenging topic of critical materials in wind turbines. We will use the magnet materials used in the electrical generator as an example. You are already familiar with the main components of a wind turbine. And as a reminder, we see here an example of where the large electrical generator is located. As the wind drives the blade round, so the generator turns and generates electricity. This is done either via the gearbox or driven directly. As already touched upon, metals are important in the design of wind turbines. Here we see a selection of key metals used in wind turbines. Some of these metals are marked as critical or strategic. You will see here 5 metals used in the magnets in the generators. These are boron, dysprosium, neodymium, praseodymium, and terbium. Today we will focus just on neodymium and dysprosium, shown as numbers 1 and 2. Let us look at neodymium in more detail. The light rare earth neodymium has some other uses, but 98% of it is used to make magnets. These magnets are used in many applications, but most are for e-vehicle drives and wind turbine generators. Neodymium provides the primary magnetic strength, making it indispensable in the generator magnets. Put simply, each turn of the blades equals more electrical power out. The material intensity of neodymium in wind turbines varies from 6 to 210 kilograms per megawatt of power of the wind turbine. The higher figures are typically found in the direct drive generators. The supply can be seen from 2 aspects. The extraction, which is currently mostly mining, and processing. Processing is the turning of the mined material into metal used to make the magnets. The extraction of neodymium is mostly from China, plus a few other countries. For the EU, this represents a 100% import dependence. A similar picture can be seen for processing, with even a higher percentage of processing being carried out in China. Again, for the EU, this represents 100% import dependence. The next step in the materials value chain is the production of magnets, where China-based companies have an even higher percentage of global supply share. 2 factors have a large effect on supply risk of a material recycling rate and substitution index. The substitution index ranges from 0 to 1. The closer to 1, the harder to substitute. If a material is highly recycled or can be easily substituted for another material, then the supply risk is lower. In the case of neodymium, the supply risk is high as it has a low rates of recycling and is currently almost impossible to substitute. Let us look at dysprosium in more detail. The heavy rare earth dysprosium has almost no other use and is primarily used to make magnets. Dysprosium increases the magnet's resistance to demagnetization at high temperatures, a vital property for ensuring the longevity and efficiency of turbines operating under extreme weather, such as very hot conditions. The material intensity of dysprosium in wind turbines varies from 1 to 21 kilograms per megawatt of power. The supply can again be seen from 2 aspects: the extraction, which is currently mostly mining, and processing. The extraction of dysprosium is mostly from China, plus a few other countries. For the EU, this represents 100% import dependence. For processing, all the processing is being carried out in China. Again, for the EU, this represents 100% import dependence. In the case of dysprosium, the supply risk is very high, as it has zero rates of recycling and is currently almost impossible to substitute. Okay, so what can we take away from this look at critical materials in the wind turbine generator? Firstly, wind turbines need critical materials because they provide essential higher performance and they help make the technology last longer. But critical materials bring challenges. They are often very difficult to substitute and often have very low recycling rates. Many countries have a high import dependence, which leads to high risk of supply insecurity. This is not just a European challenge. All countries face critical materials challenges as demand outstrips supply due to the energy and digital transitions. Thank you for joining me in this introduction to critical materials in wind turbines. In the next video, we will look at strategies to try and address the critical material challenges in wind turbines. Stay tuned.